Hi, Miss Tadros. This is Nicholas Chiappetta from your 5th period Advanced Functions class, and today I will be explaining to you what an average rate of change, otherwise known as AROC question is, and how to solve it. First things first, AROC, like I said before, is an abbreviation for average rate of change. An average rate of change is a measure of how quickly one quantity changes with respect to another quantity over a defined interval. The AROC between 2 points on a curve is the slope of the secant that runs through these 2 points. A secant is effectively a line that connects 2 points on a curve. An instantaneous rate of change is the measure of the slope of a function at a given point on a function. This represents the slope of the function at a single x value. Alternatively, the IROC at the value of x is equal to the slope of the tangent to the curve at that value of x. A tangent is a line that intersects with and is parallel to the curve at that one point. So question 7, page 87. The population of a town in thousands is described by the function p of t is equal to negative 1.5 t squared plus 36t plus 6, where t is the number of years after 2000. So question A asks, what is the average rate of change in the population between the years 2000 and 2024? B asks, does your answer to part A make sense? Does it mean that there was no change in the population from 2000 to 2024? C asks, explain your answer to part B by finding the average rate of change in the population from 2000 to 2012 and from 2012 to 2024. And D asks, for what value of t is the instantaneous rate of change in the population 0? So question A, what is the average rate of change in the population between the years 2000 and 2024? So what you're going to do here is you're going to plug in 24 into your original equation of negative 1.5 t squared plus 36t plus 6. And then that answer will be equal to p of 24 is equal to 6. So 24 is going to be your x1 and 6 is going to be your y1. So now, since you're finding the rate of change in the population between years 2000 and 2024, you're going to plug in 0 for 2000 as t. So you're going to plug that into your original equation, replacing the t. So p of 0 will also equal to 6. So 0 becomes your x2, and 6 becomes your y2. Now you'll be solving for the slope. So you're going to do y2 minus y1 over x2 minus x1. So 6 slope is equal to 6 minus 6 over 0 minus 24. So, as you know, the answer is going to be 0 because 0 cannot be divided by another number. In order to get full marks on this question, you will need to add a therefore statement. So therefore, the average rate of change in the population between years 2000 and 2024 is 0 people a year. Question B asked if my answer to part A makes sense. Does it mean that there was no change in the population from 2000 to 2024? It does make sense, because the ratio of death to births could be the same. So question C says for us to explain our answer to part B by finding the average rate of change in the population from 2000 to 2012, from 2012 to 2024. So basically what we're going to do is we're basically going to do this exact same thing that we did in question A, except we're going to do it for 2000 to 2012 and 2012 to 2024. So we're going to plug in p of 12, so 12 replaces the t in the original equation, and p of 12 will be equal to 222. So 12 now becomes your x1, and 222 becomes your y1. So you know the slope formula, m is equal to y2 minus y1 over x2 minus x1. So 6 minus 222 over 0 minus 12. M would now be equal to negative 216 over negative 12. M is equal to 18,000. So like question A, we will need to use a therefore statement in order to get full marks. So therefore, the average rate of change from 2000 to 2012 is 18,000 people a year. Part 2 of this question, we're going to need to find the average rate of change from 2012 to 2024. So we're going to use P of 24 is equal to 6, and we know P of 12 is equal to 222. So P of 24 becomes x1, 6 becomes y1, 12 becomes x2, and 222 becomes y2. And again, like the other question, we plug it into the slope formula. y2 minus y1 over x2 minus x1. M is equal to 222 minus 6 over 12 minus 24. M is equal to 216 over negative 12. And M would end up being equal to negative 18,000. Remember to always add your therefore statements to get full marks. So therefore, the average rate of change from 2012 to 2024 is negative 18,000 people a year. So essentially here, what we'll be doing here for question D, find the instantaneous rate of change when it's equal to 0, right? So, you know IROC at 0 is at the maximum and the minimum. So in order to find that, we can just complete the square using the original equation. So P of t is equal to negative 1.5 t squared plus 36t plus 6. So in order to complete the square, what you're going to have to do, factor out the negative 1.5, right? Right. Negative 1.5 t squared plus, minus 24t plus 6. So next step, what you're going to do is you're going to divide your c value by 2 and then square it to get your max and your min values. You're going to close that. Right? So now what you're going to do is P of t is equal to negative 1.5 t squared minus 24t 144. You're going to bring the negative 144 outside. Make sure to also multiply it by negative 1.5. So plus 6. A negative times a negative is a positive. And then it'll be like that. So now P of t is equal to negative 1.5 t squared minus 24t plus 144 bracket 222. So now you know here. You know one point of your vertex already is 222. It's your y value. So now you're going to factor this to find your x. And there's your vertex. It's at 12 and 222. IROC, so that's the maximum. So IROC at 0 at t is equal to 12. This graph proves question D because it shows that the IROC is equal to 0 when t is equal to 12. An example of a job that would use average rate of change would be a statistician that works for a census bureau. They calculate the average rate of change of population between each year.